This presentation describes a forensic methodological framework that has been developed for the assessment of as-built thermal bridging. Hello everyone and welcome to the SEES conference. My name is Dr. Matthew Brooke-Peat and I am the Course Director for Architectural Technology at Leeds Beckett University. I'm also the Vice President Education for the Chartered Institute of Architectural Technologists. All of the work in this presentation relates to my research at the university. Building fabric heat loss occurs via several pathways. The first of these are the plane elements, which are made up of the main floor, wall, windows, doors and roof areas that form the building envelope. Thermal bridges occur at junctions between the plane elements that add to the heat loss because of geometric or constructional reasons. Repeating thermal bridges can be present within the plane elements as a consequence of structure, ties and fixings. Air permeability, caused by cracks and gaps in the building fabric, enables unintended air exchange between the internal and external environments, which in turn removes heat from the building. Finally, thermal bypasses are situations where air movement around or through insulation reduces the effectiveness of the insulation layers. It could be argued that thermal bypasses can be completely designed out, but all other fabric heat loss paths will always be present. This presentation is concerned with thermal bridging at junctions. There is a growing body of evidence that the as-built thermal performance of building fabric is often not delivered as intended by the design. This has become known as the building fabric thermal performance gap. Thermal bridging has been recognised as a contributing factor to this performance gap. A wide range of techniques have been used to ascertain as-built fabric thermal performance of whole buildings, which can be disaggregated to identify the contribution of the different heat loss paths. The difficulty with thermal bridging is ascertaining how each bridge type influences measured performance. The purpose of the forensic methodological framework that is being presented is to assess the extent and impact of as-built thermal bridging on whole building fabric thermal performance in specific instances. It also identifies the underlying causes of the thermal bridging. The forensic methodological framework for the assessment of as-built thermal bridging is formed of 6 distinct stages. These are a review of design information, the modelling of the design, the inspection of works on site, the modelling of the as-built construction, a comparative analysis of all scenarios and states subject to study, and the analysis and treatment of results and findings. Each of these will be discussed in turn. A full understanding of the design needs to be ascertained. This requires the review of the production set, which includes all drawings and specifications, a review of manufacturer's literature for materials and components that form the building structure and fabric, a review of energy assessments at both design and as-built stages, and a review of design team thermal bridging calculations where these are available. The junction types included in the design need to be identified, and there needs to be a takeoff of plane element areas and junction lengths to establish the intended geometry of the building envelope. Baseline calculations that represent the design are prepared. These include thermal modelling of building fabric junction designs and the preparation of thermal bridging calculations, the preparation of as-designed U-value calculations for the plane elements, the preparation of as-designed HDB calculations, the preparation of as-designed Y-value calculations where necessary, and the preparation of as-designed heat transmission calculations. Forensic observations of construction works on site are made and a photographic record is created for later reference. Measured surveys are undertaken to confirm the as-built geometry. All components and materials are inspected to ascertain if the specified items have been installed. Note should be made where the as-built construction is recognised as differing from the design intent. Calculations are prepared for the as-built state. This requires all differences between the design intent and the as-built construction to be identified. As-built junctions are thermally modelled and the associated thermal bridging calculations are prepared. As-built U-value calculations are prepared. As-built HTB calculations are prepared, and corresponding as-built Y-value calculations are created where necessary. Heat transmission calculations for the entire building are prepared for the as-built state. A comparative analysis is undertaken between all as-designed and as-built calculations at both micro and macro levels. In this case, micro refers to individual junctions and plane elements, and macro relates to whole building level calculations. The claims made in energy assessments and associated calculations are compared with the baseline calculations prepared for the design intent. After the comparative analysis, the framework extends to the treatment of results and findings. These are categorized to enable exploration of the underlying causes of the thermal bridging. From this categorization, conclusions can be drawn and recommendations made of where to target action for remedial works or future development. In order for the successful implementation of the forensic methodological framework for the assessment of as-built thermal bridging, there are several issues that may need to be addressed depending on the specific scenario encountered. Firstly, the availability of input data can present challenges. Problems with the supply of design information are well recorded as an issue in the body of research. For example, drawings may not be provided for all junction details, and this means that only the as-built state can be thermally modelled. Not all manufacturers ascertain and publish all of the information required when their product is to be incorporated into a junction that is to be thermally modelled. For example, manufacturers of acoustic insulation often do not confirm thermal conductivity. This is understandable because the insulation does not usually form part of the thermal insulation strategy. However, acoustic insulation is often positioned where it can influence the thermal performance of the building fabric. For example, where the edge of the insulation in the floor shown on screen reduces the heat flow to the wall locally to the intermediate floor junction. The framework is applicable to works for existing buildings where the existing fabric adds complication in the assessment of the as-designed state. The geometry and nature of the fabric will need to be surveyed in these instances. This could prove problematic for certain plane elements such as ground-bearing floors, but it is not insurmountable to deal with these constructions. The thermal conductivities of the materials that form the existing fabric will need to be obtained through sampling and testing in most cases. That is, unless accurate matching can be achieved with samples of known properties. The environmental conditions and their effect on the existing building will need to be accounted for because these will determine moisture content, which has an influence on thermal behaviour. Site visits need to be undertaken at regular intervals that correspond with the construction process. Inspections must be made to gather data before work is covered over by subsequent phases. Access will need to be coordinated with the contractors to ensure that the research does not adversely affect their programme. A strategy is required to mitigate against the Hawthorne effect, where contractors present their better work for inspection because they are aware it is under scrutiny. This can be achieved by making observations of works to adjacent constructions where available. The standards and convention that govern the assessment of thermal bridging can be a limitation that needs to be overcome. For example, there is no established procedure for thermal modelling of a party wall ground floor junction where the finished floor levels are different to either side of the party wall. In these instances, solutions need to be devised to enable the accounting of heat loss from these junction types. Another issue is how thermal bridges are treated at the macro scale in the calculation of whole building heat loss. All junctions are accounted for in the assessment of as-designed and as-built states when applying the framework. However, conventions for the assessment of energy use and carbon dioxide emissions often neglect some junction types. For example, the table shown on screen shows the junctions and associated psi values calculated that were excluded by the UK Government Standard Assessment Procedure in the rating of a case study dwelling. The types of junctions excluded from energy assessments is a factor that must be addressed when comparing these with the calculated as-designed and as-built values. A forensic-based methodological framework has been presented that can quantify the extent of as-built thermal bridging and its impact on whole building fabric thermal performance. To recap, this framework involves the review of design information, the thermal modelling of the as-designed state, undertaking site inspections and surveys of construction works in progress, the thermal modelling of the as-built state, the preparation of micro and macro level heat loss calculations, the undertaking of a comparative analysis, and the categorisation of findings. The framework permits comparisons to be made between different assessment scenarios in both as-designed and as-built states. The framework can reveal the nature of as-built thermal bridging by identifying the underlying causes of its extent and impact. This enables the categorisation and further subcategorisation of findings to focus attention to areas of design, construction or assessment that need improvement. Please feel free to make contact if you have any questions about this presentation or wish to discuss anything else related to building fabric performance or architectural technology.